One of my favorite parts of working on a destruction shot is to use hacks or tricks to add details to the static areas. If we look back at my version of the shot here, you can see that the back walls look completely undamaged, and even these sections of the floor and walls that have been damaged, the remaining section looks very straight and perfectly intact. And one of my favorite ways to break this up is to randomly rotate all of those pieces to make it look like there are lots of cracks across the surface. Now, because we really want to art direct the look of this, I'm not going to apply these changes to the simulation points. I want to apply it to the geometry directly. So I'll start by bringing in our fractured geometry from our sim section of the setup. We're not bringing in the simulated transform geometry, we're just bringing in that rest pose of the fractured geometry before the simulation. And you could do this with the proxies instead, but I really prefer to see exactly what all of these cracks look like with the high-res geometry. But in order to see this geometry, we'll need to use a packed edit to change the display to full geometry instead of bounding boxes. And since we really only want to apply these changes to the areas of the simulation that never move throughout the shot, we're going to need to get that active frame information that we calculated at the beginning of our post-sim tweak setup. So, as I've mentioned before, you could drag a wire from this active frame attribute section there all the way down here, but that can get a bit messy, so I'm just going to do an object merge and point that to /active frame attribute to pull in that data here. Now, currently, the fracture has the name attribute on prims, but these active frame points have it on points, so I'm going to temporarily promote our name on the fracture geometry from prims to points. So original class is primitive, select that name attribute, and now we can copy over this active frame from our points. So I'll drop in an attribute copy, connect the fracture geometry to the first input, sim points to the second, and for the attribute name, we'll select active frame, and we'll delete that color because we don't need that. And we'll turn on this match by attribute option, and we'll match by the name attribute. And since that's a point attribute on both of our inputs here, we don't need to change any other options in order for that to work correctly. And since this was just a temporary name attribute promotion, I'm going to push that back down to prims with another promote after we do that copy. So original class point, new class prims, and select the name. And now we can use a split node to just isolate the static portion of the building. So in this split, for the group, we're going to type @ActiveFrame is equal to 10,000 because that was the default value, and it'll still be 10,000 if it has never activated in the simulation. And we'll need to change that group type to points in order for that split to work. And now you can see this has successfully isolated the static area. But we'll want to animate the cracks appearing on the surface based on when the nearby areas start to move. We don't want the cracks to be always visible all the time, so I'm going to transfer the active frame from the nearby active pieces onto the static section so that we know when its closest neighbor starts to move. So you can use an attribute transfer and connect our static area to the first input of that, and I'll call this attribute transfer active frame, and we'll turn off primitives, and for the points we can wire in the active portion of the building, and then that will allow us to pick the active frame from the points drop down parameter there. And we want this to just pick up the nearest point regardless of distance. So on the conditions for the attribute transfer, you can just turn off this distance threshold so it'll just grab the nearest point regardless of how close or how far it is. And if we check the spreadsheet for our attribute transfer, you should see that now we have lots of different active frame values and we no longer have any values of 10,000. Now I'll use an attribute randomize to set up the amount of rotation on each piece. So in that randomize, I'll just create a new attribute called rotate. And for the range of this, we'll set the min values to -1 for both x, y, and z. And we want this to be 3 dimensions because we're going to rotate it on all 3 dimensions. And right now this will only give us 1 degree of rotation, which is going to be far too subtle. And sometimes you want this cracking effect to be really subtle, but you can easily control how heavy-handed that is with this global scale parameter here. So I'll just change that to 10, so that'll give us plus and minus 10 degrees on each dimension. And now to apply each of those randomized rotations, I'm going to use a for each loop. We'll use for each named primitive and connect our randomize to that. And inside that loop, we'll drop in a transform. And the pivot for this is going to be our centroid. So we'll just use our centroid function once again. So that'll be centroid of input 0 for d underscore x, d underscore y, and d underscore z. And I keep forgetting to make a preset for this, so I'm going to do that now. If you go to that gear icon, then select Save Preset, and I'll call this centroid pivot, and save preset. You could potentially set this as your permanent defaults if you would like. And then for the rotations, we're going to do a point lookup for our input piece. So if you display the for each begin, it'll just show one piece at a time. And if you look at the spreadsheet for that piece, there's this rotate value that we set up with that attribute randomize. So we can just look up point 0 and grab that rotate x, y, and z attribute. So in that parameter, I'll type point to do a point attribute lookup from input 0, then point 0, and the attribute called rotate. And since we just want x for this first one, I'll put in 0 for that final float. And then for y, we'll paste in the same thing, but change that final 0 to a 1 to grab the y. And then for z, we'll change that to a 2. Now if we display that transform, you'll see a slight rotation on that piece there. And if we display the end of that loop, we should see all of our pieces individually rotated just a little bit. You can see that this has introduced lots of interesting cracking detail all over our building. Now you could make this much more interesting. You could potentially use some sort of a noise to vary up the amount of rotations in different areas. It could be pretty cool to have some areas with very subtle or no rotation and others be a bit heavier. But for now, I chose to leave it like this, since a lot of this is really going to be covered up by dust anyway. And this is also really nice on the edges of this area as well, because this starts to break up that super regular hole shape that we saw from the raw RVD sim. Anytime that you have this sort of perfectly intact area around the edges of that simulated section, it looks pretty fake and cut out. And adding these crack rotations makes it look a whole lot more natural. However, you'll notice at this point, this is actually not time dependent at all. We're just doing this on one static pose, and we're going to need to animate these rotations. And we can do that with a little bit of Vex just before this loop where we're applying the rotations. I'll add a point wrangle, and I'll call this rotate anim. Now this bit of Vex here will add a multiplier on that rotation amount based on the active frame of each piece. So if a given piece activates at frame 1000, this will create a blend from one frame before that active frame to 5 frames afterwards. So it's blending over 6 frames from 0 to 1 as a multiplier on that rotation, which will effectively animate it across the surface. So we're at frame 1080 now, and if we look at our cracked geometry, you can see pretty much everything has that crack rotation applied here. But if we jump to an early frame in the simulation, like perhaps frame 1000, And I'll also hide our creature for the moment so that we can see this a bit more clearly. You can see that only the areas near the moving simulation pieces are getting that crack rotation applied. Now if we run a flipbook with those random rotations applied and with that animation based on the active frame, you can see those crack areas spreading across the static portion of the building as the nearby areas are broken away.